All right, just so everybody's aware, we are recording this, and the recording will be available to view on our YouTube page in a few days after the webinar. But thanks so much for joining us today, everybody. Um, Today's webinar is all about air-to-water heat pumps and ground source heat pumps for existing homes with radiant heating systems. Like I just said, again, this is being recorded and will be available for viewing at a later time. We'll follow up with an email with all sorts of information, our slides, as well as a link to that recording. Thanks for everybody for joining us today. Dave, if you could hit the next slide, please. Okay, so this is the third in our summer heat pump webinar series. Just so everybody knows, we did have one scheduled for June 19th for ducted heat pump systems. Unfortunately, we did have to reschedule that. It is now going to happen on July 24th. You don't need to do anything, read, register, anything like that. The links that you have for your current registration, if you are registered for that webinar, will still work. Just wanted to make you aware of the date change. Again, next webinar is on July 24th for ducted heat pump systems. And
we do have one on July 10th. Don't forget. Yeah, the next one's actually July 10th, but
yes. Thanks, Dave. Dave, you could hit next slide. Thanks. Want to give a big thank you to all of our 2024 webinar sponsors. Sponsors include Core, Energy Smart Colorado, Beneficial Electrification League of Colorado, Holy Cross Energy, Clear, Tri-State Energy Co-ops, as well as High Country Conservation Center. So lots of thanks to all of our sponsors. We couldn't put this on without you all. This is kind of a snapshot of all of the Energy Smart Colorado partner organizations in different areas all throughout Colorado. So all of these organizations can provide all sorts of information for what incentives might be available for heat pumps in your area. So please reach out to them if you have questions about heat pumps or what incentives might be out there. And Dave Petroy, our presenter. Sorry, Dave, I think we might have missed a couple slides there, but that's okay. We can send them out in our follow-up email. We'll have a few additional slides here at the start, but we'll go ahead and get started. I'd love to introduce our heat pump expert and presenter tonight, David Petroy with NTS Energy. David has well over 15 years of experience in a range of renewable energy and sustainability business roles. He was the founder president of Blue Valley Energy, which is a successful ground source heat pump engineering and installation company in Boulder with over 200 installations throughout Colorado. During the early 2000s, he led technical sales of solar and energy power systems for residential and small commercial businesses at RMS Electric. And at Golden Aluminum, one of the largest single-site industrial power users in Colorado, David was responsible for leading the adoption and implementation of a facility-wide energy monitoring system and upgrades to reduce energy consumption on those large industrial production processes. Most recently, he did consulting work with Xcel Energy, helping customers understand their energy usage. And in 2017, he launched NTS Energy, a consulting company focused on providing advanced HVAC and solar solutions to homeowners and small commercial companies, while also promoting the transition to the new energy economy here in Colorado. David holds a master's in geophysics from Washington University in St. Louis and has a bachelor's in zoology from SUNY Oswego. So, David, please take it away.
Thanks, Diego. So today we're going to talk about two kinds of systems. One is called air source heat pump, air to water, and some it's referred to as hydronic heat pumps, and ground source heat pumps. We're going to focus on homes that are radiantly heated. We will touch a little bit on new homes, but the next webinar is going to really dive into the new homes application of this. So we got several topics. One is to talk a bit about heat pumps, how they've evolved. We'll talk about how to evaluate your existing radiant system, because that's very important. And then we'll go through the two technologies, and then we'll talk a little about selecting a contractor and how to make sure when you're looking at these technologies, how you know that you're going to get a good system. So why, heat pumps in general, why are we going to them? Well, in general, there's a lot lower energy use because they're not creating heat. They're just moving it from the outside to the inside. They can save quite a bit on your bills versus electric or propane if you're in that situation. Natural gas, it's kind of on par, depending on what the winter costs are of gas. Number three, there's a dramatic reduction in your heating systems, air pollution, and GHG systems over the lifespan. And for ground source heat pumps, it's kind of the top of the line, most effective system. And the beauty of it is it lasts for a long time. These loops are in the ground for 50 years plus, and the inside units last longer than other types of systems.
David, sorry to interrupt. Just wanted to mention, sorry folks, there is a Q&A box. Forgot to mention that at the start. If you have any questions, please enter them in that Q&A box, and we will answer them at the end of the presentation. Sorry, Dave, take it away.
No worries. So this is why this technology is really developed over the past 15 years. In the 2000, applying heat pumps in Colorado would have been very limited, but now we've got cold climate heat pumps. And so what has happened? This little graph shows one of the big improvements. So the bottom axis is outdoor temperature, just from 0 to 60. The vertical axis is how much energy or BTUs is required to heat your home per hour. And this green line is for kind of a house, typical house, 2,000 to 3,000 square feet. This is how much it takes to heat the house at various outdoor temperatures, increasing as it gets colder. So back in the last century and up to 2000, basically heat pumps, the thin blue line was how much energy or how much heating a heat pump could provide at a certain size. And notice the crossover point. And it was really down to about 30, the mid 30s, down to about freezing. Heat pumps would have enough heating to heat a house, and then you would need other technologies. But over the last time, they keep improving all the technologies, everything from fans to computer boards to compressors, and they kept upping the technology's ability to heat at cold temperatures. And the orange line is now a system called the cold climate, and notice that it basically maintains its heating capacity down to 0, and even they go down to about -13. They tail off a little bit, but this is a giant step forward. This entire yellow box now can be done by a heat pump. This little tan box is something you usually pair these with a little bit of supplemental heat. Not much, and we'll talk in detail about that. Number two is efficiency. And this is like from 2012 to 2022. We're about here in 2024 because the manufacturers are focused on new refrigerant technologies. It's due in 25. So HSPF2 is it's a measure of heating efficiency over the heating season. The higher the number, the better. And you can see how it's just steady progress every couple years, better and better. And the orange line represents the percent improvement. So really about 25, 30% improvement since 2012, which directly translates into lower operating costs, lower heating costs. So basically you've got these efficiency improvements, You've got higher capacities below 30. You've got the ability to heat below 0. And the other thing, which I didn't go into details, but improved defrosting capabilities. So if you think about the times around freezing when it gets sleeting, or even in blizzards in the heart of winter, that it could start to build up some snow and ice on these outdoor units, and they can reverse now and quickly melt all that. So that was another very important. Now, if you've got a house with radiant heating, there's really a key principle that we need to start with. And these technologies, the air to water, ground source heat pump, they work with radiant heating distribution systems that heat the home when the water temperatures required are 120 F or lower. So lower temperature distribution systems that can heat your home. And actually, that's the most efficient way. Even if you were heating with a boiler, it's more efficient to heat with lower water temperatures than have to heat the water up to 150%. So in order for these systems to work, it should be able to, the system basically, if it can heat the home between 95 and 115 at 20 degrees outdoor for existing homes, then that's good. For new homes, and we'll talk a little bit about new homes, but new homes, you want to set the bar a little bit higher because you can design your system from the get-go. So if your boiler setting, and you talk to your HVAC boiler expert and say, what's my boiler output temp setting? If they say 120 or lower, you're good to go. Now, so we have radiant floor systems, and I'm going to call them the low heating ones. And those are typically in gypcrete. So typically this is gypcrete or concrete over the tubing because it's got a very high conductivity. So it doesn't need a lot of high temperatures. So that typically is one. Warm board systems. Warm board is actually one of the manufacturers. I'm using it kind of as a generic term. I'll show you that. That's where it's on top of it. And underfloor staple ups that are designed for very low temperatures. There's a big difference in those systems. So I will talk about that. Now, the other thing, though, and this is probably more cases for existing homes than lower temperatures, because y'all have boilers, is the radiant, and they're called high heating temperatures. So the radiant underfloor systems are designed to heat with higher temperatures. And this is kind of a simple one. You just put a few tubes under the floor. This is not completely finished. I'm sure they're going to insulate and do more, but not a high density of tubes, not plates. So you're going to require water temperatures 130, 140%. So you really got two choices in this case, if your system is like that. You can improve this, and we'll talk about many different ways to improve your radiant distribution system. Or you can, what I'm going to call, migrate from radiant heating to mini split heat pump system. You can basically, what you can do is leave your radiant system in place and use it with the boiler for the most coldest times, only a couple months a year. And then you can use mini split technologies throughout the home to do the other 10 months of the year. And we have webinars all about mini splits, so I would refer you back to those. Now with baseboards, typically baseboards are designed for really high temperatures, and it's a big challenge. I can say that the way these technologies are evolving, I expect in about 5 years, they'll have systems that can really do these higher temperatures at any kind of efficiency level, but we're really not there yet. So your options are the same. You got to figure out ways to put supplemental type radiators, etc., where you can migrate. So let's talk about, you have a home and you want to migrate and you want to use heat pump technologies. There's a few things you can do. If you're at a point where you want to redo some flooring, this warm board. It's very wonderful technology. You have these sub panels. They're very thin for retrofits, less than an inch. And then you can have, they have all types of flooring for on top. Wooden tile, hardwoods and tiles are obviously the best for conductivity. The nice thing about these kind of systems is they're very responsive. Concrete and gypcrete systems are good in a way that once you heat them, they hold it, which is good for the winter. But the spring and the fall, where there's days where we need heating and that heating has to shut off, etc., these types of systems are good. And just because we're looking at them, note this is a nice option to think about for new homes. Now, if you've got baseboards, you can leave the baseboards in, or you could substitute certain lengths, take certain ones out, and put these radiant panels in, which used to be just one boring design. Now people put a lot of work. I mean, you can get these in bathrooms, towel racks, all kind of stuff. These are high output because you really have a lot more surface area. The way they've constructed them, they designed to put high output. So what you can do is think about your rooms and put these kind of panels in. The other thing is if you have that underfloor already, or you have a floor, like say your main floor in your basement, you can have access. You can put in an underfloor system that's low temperature. There's a few principles you need to think about. One is you need to have what's called heat transfer plates. So this, the hot water is going through the tubes, but this is driving it up across the whole floor. That's number one. Number two is you put foil below the transfer plates, reflecting any heat up. And the third thing is you insulate really well between the joists. And now that we have higher R values per inch, you can really cram a lot of it. And basically, by doing all this, the temperature required into the tubing is very low. So you could do one of two things. You can upgrade what you have already, or if you have access, this is a strategy that you could use. Now, the new homes are going to be talked about in a few weeks, but for those of you who are here and might not be there, basically you're starting from the get-go and you're going to say to whoever who you're working with, I want a distribution system that runs at low temperatures when the outdoor air is like 0. And the warm board or the on surface is one very good way to go. Gypcrete, concrete. Mainly it gets down to, or even underfloor, it just gets down to higher density pipes and making sure that it's going to transmit that. And also with the new home, you want to think about cooling. You can do radiant heating and air cooling with this and I have a slide to talk about air handlers for that. So let's talk about air to water, or the other one is the hydronic system. So the hydronic system has an outdoor unit. It looks much like other mini split or other kind of air to air heat pumps. It's generally larger. And what it does is it, converts it to a refrigerant, and in here is another indoor unit that basically a refrigerant. There's a heat exchanger, and it exchanges to water. It heats the water in a tank, and you'll have some supplemental in a tank or other one. And I'll explain that in a couple slides. And then basically, if this is, instead of your boiler, this is your heating source, goes out to heat the units. Some cases, you might have a little supplemental boiler that you use, and I'll talk about that in a slide or two. This is just a different configuration. You've got an outdoor unit, sort of more intelligent. All this is kind of combined into one. So there's various ways these systems are designed. There's also one called a monoblock, which means it's all water. There's not a real refrigerant, but use glycol. The exchanges out here, I don't think they're used quite as much. So I mentioned they're going to be a supplementary heating source, and it's really going to be, it's going to either be, the heat pump's going to do the majority of the 85% plus. So if it's an electric scenario, and this depends on the designer and kind of what they want to do, all of these are kind of good strategies. You can either have electric in the water tank, which turns on, let's say my system is designed to run at 110 degrees. The heat pump can do it to 110 all the way down to say 10 degrees. Then it needs a little boost. So that's how it'll work. Or you can either have on the side a little electric boiler. Some designer, he does that because he says the tanks last long. If you have natural gas, you have the option, you can keep your boiler and hook it in if you've got a boiler that's not very old, or on-demand water heater, or you can do that. So these are the strategies to do that. And one thing to keep in mind for those of you would be, if you do want to go all electric, you have to think about your electrical capacity. The heat pump uses 220 volts. It's going to usually use like 40 amps. And then if you want to do some of the electric, you might need another 30 amps or so. You might not have enough without upgrading your electrical service. And you can obviously do that, but it's an expensive proposition. If you have gas available, just use that and save your electrical capacity for some other application like domestic hot water or an EV. So with these systems, you got to think about when you're working with your contractor or designer, how big a one do I want? And you got to design for Colorado. And so the systems are rated, and you'll say a nominal 5 tons. So just so everybody knows what a ton is, 1 ton is 12,000 BTU per hour heating. Most homes, newer homes, well insulated, they're in the 3 to 5 ton range for the average kind of homes. So a 5-ton system, they say it's 5 ton, but it's 60,000 BTU at sea level and 47 outdoor. And even though I said, these things tend to hold it, that's true, but the elevation has a big impact overall because you've got colder air, and these systems do tend to lose a little bit at colder temperatures, these air to water, more so than air to air, because it's thermodynamically hard to heat water. So when they size it, they'll be sizing like 5 ton for 40,000 BTU. Now, remember I said that the water temperature is really important, and here's why. With these systems, if my in-floor system requires 95 water temperature, I have a coefficient performance around 3. Coefficient performance says it's a measure 1 unit of energy in, how many units of energy out. And heat pumps move energy. So 1 unit in, 3 units out. But if I have to heat my water warmer and warmer, hotter and hotter to do this, notice how for these systems that coefficient performance can drop. It's still good and it still works. That's why with retrofits 120, I say if you can get below 120, you can do this. For new homes, you really want to shoot for these lower temperatures. And so how big a system? Well, with an existing home, you really want the heat pump to go to 20 degrees or less outdoor, carry the whole home, heat the whole home, and then the supplemental work together. If you're using electrical, you want to get lower, simply because as the supplemental versus gas, because electrical is just straight up electric is more expensive. New homes, you want to set a higher. So what about cooling? The way it works with cooling is you have this tank and this heat pump. The heat pump can make the tank hot or cold. And so what you'd have is connected to the tank, you'd have these things, air handlers, where you've got hydronics going to water. And so these have subducting. So depending on what parts of the house you want cooled, and these can be big or they can be small, and that's the way to go. Now, often Colorado, you might set up a 2-tank system with a smaller cooling tank, simply because in the spring and the fall, there are days where you're going to go cooling and then maybe a little heating back and forth. And so rather than having this heat pump convert this tank back and forth, you just have a little cooling tank that basically does the summer. Now, how much do these things cost? So this is air source heat pump, air to water. What's the cost? So the system costs about $1.25 to $1.50 per BTU. So an example is if you have a 40,000 BTU load, it's gonna cost you somewhere in the order of 50 to 60,000. This is, say, a couple thousand square foot house. So this is just guidance, it's a range, but that's kind of where you're at, and that involves this kind of whole system up here. It does not involve these air handler systems. So what do you get any cost savings, or what is it? And remember, I said these COPs are higher. And so you've basically over the year, you save about 40% of the energy, or you only use about 40% of the energy. So it's going to cut your bill. Propane and electric, going to cut it by 60%. Gas still per unit of energy is pretty inexpensive. Some years it goes way up, some years down, roughly on par. In other words, some years the heat pump system might save some money. Other years it might be even, maybe a little lower, up and down, plus or minus 10%. And I think this lower right is to show everyone, it's a little surprising, but like an Eagle, this is outdoor temperature, -20 all the way up to 65. And this is percent of annual heating energy use. And you can see that even though it's really cold in the winter, because of the hours, above 15 degrees is about 80, between 80 and 85% of the annual heating load. So this is what the heat pump's going to take care of. And then in here, it's going to work together with the supplemental. So you're getting a big boost out of it. And this is outdoor temperature average. And so what happens really all the way from like mid-February to November, it's the heat pump's doing its thing, and then it needs a bit in the dead of winter. So what about greenhouse gas? And also I would just say, general pollution emissions. And we're getting so much better on that front. So this is in 2020. This is kind of the annual emissions in pounds. And in 2020, our utilities were starting their path. There still was a lot of fossil fuels, and you can see like these were the heat pumps here, the orange and blue, cold climate, if it was just total heat pump, and the gas is in here. So notice there's not a lot of difference. Now, this is 2027, and I'll tell you that I've been looking at the 2023, 2024, and the major utilities are all, they're doing well. They're on track in how they're converting the grid. And notice these huge drops in amount of emissions. And also, if I go out, I've done runs where out to 2030, 35, these are going to keep falling. And realize that you're buying this system for 15 years. So there's you're going to save quite a bit on your emissions. So these systems are available in Colorado. They're somewhat limited in the number of people doing them, but there's some good folks out there. Arctic Heat Pumps is a company called BrightSense. He's kind of the hub, the distributor and also designer, and he can say it with contractors. This is the distributor here and designer. This is a newer kid on the block, pretty high tech. And then Space Pack. This Temper-Air group is the product rep, and they can put you in touch with some of the contractors. So those are kind of three of the players available in Colorado. So let's talk a bit about ground source heat pumps. And I got about maybe 10 minutes to go here. So here's the components. You've got the loop. You've got called the manifold, which is the trenching that connects all these loops. Then you've got your indoor unit. So the water from the loops come in here. That's your energy source into the unit. This is a air system. Let's look at the next slide. Air system. The right is a water to water, ground source heat pump for hydronics. And so the loop comes in and it basically feeds this tank and heats it. Now, for those of you who want, this is a very interesting option by the manufacturers. It's very good. It's a combo. So this heat pump compressor can heat water for radiant system, but also sitting on top is a air system, so you can use that for cooling. This is in particular if you're thinking about in a new home situations, it's good. It could potentially be a retrofit in the basement if you want to use this to heat the main floor or something. So there's a really good combination of technology. So we're going to first talk about, you'll read about horizontal loops and vertical loops. Now in Colorado and anywhere, you need a lot of land for the horizontal loops, meaning you're sort of, in the eastern part of Colorado, or maybe somewhat out near Grand Junction. The drier, and these typically will go down about 6 feet or so, 4 to 6 feet, but actually 6 feet is really where they're at. Now, what influences how big is how dry these soils are in the winter. And we do have fairly dry soils in the winter, so we might have to have bigger loops than, say, Iowa or something. The real thing about saving money on these is if you have the ability to dig these trenches and these loops, either with your own equipment or some relationship with someone who can do this very inexpensively, then it is more cost effective than vertical loops. But most of the time in Colorado, land, dry soils, we're looking at vertical loops. And what you do is you think about it per ton. So, 1 hole per ton. So probably commonly you're looking at four or 5 holes. That's for a 4 to 5 ton system. Bigger houses, which this technology is probably most cost effective for, are typically going to, you could have 8, 9 holes. The holes are 15 feet apart. You dig a trench to connect them. And so the way this works is basically the earth is the heating source. In Colorado, the average temperature of the earth is between 45 and 55, depending on where you are year round. What happens is this in the winter extracts heat from the earth. And depending on the soils or the rocks, it starts pulling heat out. The earth will cool down some. It might end up being in the range of, it'll start cooling down. So your water will come up, say, up down to 35. The system's still super efficient, works that way. That's the design. In the summer, you're pushing heat back into the ground, and that might heat up. Now, so what you do in design is you say, I have this house and need just much heat. It's in this climate zone. And I have this specific ground source heat pump system. And basically I want to control the temperature. I don't want it to go below 35. And well, in Colorado, we're heating dominated, so the cooling will be easy for it. Now, the systems still work. I mean, they work down to 30 degrees or so, but you want them to stay efficient. So it's a trade-off. I do a little more, you do a little more loop, keep it efficient. Just as an aside story, if I'm in Texas, this is a different problem. It's in the summer and throughout the year. I'm pushing a lot of heat into the ground. And I might not have a lot of winter to pull it out. So I have to have really big loops to make sure I can push heat into the ground and it dissipates out. Otherwise, when I was doing this, there were cases where the loops weren't big enough and it just got warm. Different problem. So there's a big cost variables in this. And first of all, you're mobilizing big equipment. You're driving it, depending on where you're, Colorado, far away. In existing homes, it's a challenge. It's actually fun. You figure out, how do I fit these things in little spaces? And you can do it. And then how do I get the trench? Where do I put it? How do I get it in? So that's a little bit, but the geology and the drilling is really the big deal. For example, if I'm in hard rocks, it's diamond bits, it might be slower, but I know it's going to be steady. One of the hardest conditions to drill is like up in the foothills, because it's sort of these glacial outwashes, these alluvial fans, and there's boulders and geology varies. And so you could be changing bits, etc. So That's a little challenge in Colorado. Now the drillers have drilled enough all over the state that they have a good sense of what's going to be easy, what's going to be tricky. So the installation cost is a bit more. It's definitely more. And for an example of 40,000, you've got quite a high cost. But here's the big equalizer. There's a 30% federal tax credit. So pricing of this goes down to that. Still, not an inexpensive prospect. And these COPs are higher, so they're going to cut your bill more and lower your cost a bit more because you're using the earth rather than the air temperature. So I mentioned this before, but I kind of want to illustrate it. This is how you use heat. You've got space heating, water heating, and cooling. My last slide, remember this, these are this, and then there's other uses, little things, but honestly, I could put in here a big block called driving your car. So there's kind of the big four, and by putting in a heat pump, you're really attacking these two. So let's compare. You've got, radiant in-floor or baseboard heating. Or, you've got a system where it's lower temperature, you can do this. So this kind of just gives a comparison about how much heating and the efficiencies and longevity between ground source, air source, and this is, mini splits for 3 season and keeping the boiler. So it's just kind of a little comparison chart. This is a little pricing comparison chart for like a 4-ton system. Now notice here, this number can vary greatly with the geology. And I've added this in because, this system mini split, you get cooling with the air. But if you want to add in ducts and air handler, it's addition to this. So kind of to get it apples to apples comparison. So radiant systems, we've talked about, you got to get low temperature, new homes, high efficiency, radiant. So in general, I think if you're looking for some guidance, if you have a house that's 4 tons or less, let's say 4,000 square feet or less, you can look at this, you can look at 2 things. You can do the air source, air to water, or you can look at the mini split conversion. If you've got a bigger houses, then the ground source heat pump system is something worth really looking at because there's sort of this minimum amount. Doesn't mean that you can't do it. People do it for small homes, but just realize it might not be the way to go. And ground source heat pump contractors, they've been doing it for a long time. I did it in the early part of 2000s. There's enough contractors, there's drillers. Just be aware there's kind of a lag time, but this is a well-established industry, though limited, kind of niche. Air source heat pump for radiant, these systems, I mentioned the 3 systems and the designers. It's a little bit newer in terms of people doing it. I'm not going to mention that, I'm not going to talk about this, but if you're tight houses and stuff, you need to look at these heat recovery and you need to think about fresh air systems. So I'm going to read that slide. So how do we get a good heat pump system? We're going to talk about these few topics. So what has happened in the past still happens sometimes. First of all, they're not a cold climate heat pump. And so what's going on is you're getting the old style heat pump down to 30 and then putting in electrical, and it's using a lot of energy rather than a cold climate. It's not, you're not designing a size right or the right temperatures. So you end up with undersized or poorly installed. And so these are the 2 things that happen. They don't work when it's very cold. Now, remember I said they can go down to the negatives, but alone, they're not going to necessarily do it. You need a little complementary, because otherwise you'd have to design a huge system. It wouldn't make sense. And heating costs are much more expected. 90% of the time, what this is the heat pump isn't, you have a heat pump with electrical supplement, and the heat pump's only to 30, and then you're using tons of electrical. Whereas, as I've said, at least 20 outdoor, 10 outdoor. to do that. So those are two big things. How do you know you're getting a good system? Variable speed compressor, all these systems, these air to water and the ground source are very high end. So they can do these things. You want to make sure that it meets all the requirements for any utility credits and the federal tax credit. This is probably the most important things. What's the warranty, particularly the compressor warranty? They do vary, and that's really reflection. So I always recommend getting extended warranties for these systems. Finally, on a little bit more air to water, you want to make sure that it's covered. You want to make sure it's high enough off the snow in the south corners, good. You want to make sure it's drained right. So you can ask the contractor, can you show me some installation? Contractors, I've mentioned a couple times, you want them to have experience with these specific things. For the ground source heat pumps loops, they use an IGSPA certified contractor. And that's a national organization that certifies contractors to put in loops, and get a couple of quotes on it. I think the one thing, and this isn't so much for these because they're really higher end, more specialized, people aren't going to do an online purchase and put them in. But the funny thing is, a couple of these air to water sites will give you an estimate of what it will cost for the equipment, but don't be deceived. I mean, that's the equipment sitting on the factory floor. That's not, the distributor brings it in and all the stuff. So there can be quite a difference. Don't be fooled by that. Summary, evaluate your radiant system, upgrade. The air to waters work well as long as you got that system, the radiant distribution system. Ground source heat pump, most energy saving, longest lifespan, larger homes. Make sure you've got some knowledge, and really get trust in your contractor designer for these systems. There are some really good people out there, and you're going to have some big benefits. And I'll go back to the big four. You got the heating, the driving, the domestic hot water. And so the question is, if you're thinking about this stuff, which one or two are you going to go after in the next 5 years? This excludes air travel, which is in the home. And thank you, everyone. Diego, back to you.
Thanks so much, Dave. Appreciate that extensive presentation. Folks, this is just a reminder that Energy Smart Colorado operates throughout rural Colorado. All of these different regions each have a different Energy Smart Colorado partner organization. So if you have any questions about energy usage in your home or business, or want to know about incentives for heat pumps, please reach out to those local organizations in your area for more information. This is a snapshot of some of the rebates that are available from some of our local Energy Smart partners. So High Country Conservation Center over in Summit County, folks who make up to 160% of the area median income can get up to $4,000 for a heat pump or heat pump water heater rebate. Folks who make over 160% AMI can get $1,000 in rebates for a heat pump system. CORE is the organization over in the Roaring Fork Valley, serving Pitkin and a portion of Eagle counties. Their rebates are 50% of the project cost. Folks who make up to 150% AMI or qualify as a community priority participant can get up to $15,000 in rebate. Over that 150% AMI can get up to $7,500 in rebate. CORE also has some grant funding available for new construction projects. Clear over in Carbondale, serving Garfield County, and specifically for Glenwood Springs Electric customers, folks can get 50% up to $2,000 and up to $3,000 for and 50% up to $3,000 if you make under 150% of the area median income. Also, if you are an Excel electric customer, Excel provides up to $2,200 for cold climate heat pumps and up to $800 for heat pump water heaters for rebates. And then over here in Eagle County, the Eagle River Valley, so Vail to Dot folks can get 25% of the project cost back up to $1,000 for a heat pump or heat pump water heater rebate. If you make under 150% of the area median income, we encourage you to apply for our Re-Energize Eagle County program, which is a little bit different from our standard rebate program. So if you have questions about any of these rebates from any of these entities, please reach out to them if you're in their area. There's contact information and websites right there for you. So you can click those links when we send these slides out at the end. Holy Cross Energy also has rebates available for heat pump installations. For income qualified folks making up to 150% area median income, you can get 50% of your project costs back up to $7,500 for the year. If you make over 150% or don't wish to qualify, then you can get 25% of your project costs back up to $3,000 per year for a heat pump install. And then commercial and multifamily rebates also exist, up to $7,500 for commercial multifamily projects. And that also goes for us here at Walking Mountains. We do have separate rebates for commercial buildings and multifamily buildings, including property associations. So tri-state co-op members also have rebates available. So if you are part of a tri-state co-op, please reach out to that co-op to see what's available for incentives in your area. And there are tax credits available for heat pump installations. So there's a federal tax credit, 30% of the project cost, you can claim up to $2,000. Heat pumps that have earned the Energy Star are eligible for the tax credit. Here in Colorado, they do need to be cold climate rated. And then there's a Colorado state tax credit of up to $500. You need to use a registered contractor, and that contractor passes on that credit as a discount to you on your final cost. As always, we definitely advise you to seek the advice of a tax expert to confirm your eligibility for any of these tax credits.
And we need to add, I mentioned the federal tax credit for ground source is 30% of the project cost. So
with no cap. Thanks for that, Dave. Okay, and loveelectric.org is a great website with lots of information on it. They've got all sorts of info regarding rebates for heat pumps in Colorado. They outline the benefits of switching from gas, propane, or electric resistance heating to efficient electric equipment like heat pumps, heat pump water heaters, or induction technology for cooking. They also provide some explanations and rough cost estimates for the best heat pump applications for your home. And they also host a list of qualified installers of heat pumps. So if you have some further questions, check out loveelectric.org. They're a great resource. And last but not least, thank you everybody for joining us. We really appreciate your attendance, and we have just a few questions here to answer right at the end. So Dave, first question from Scott. Can the outside heat pump be installed in a garage or a storage shed? So that outside condenser, can you actually install it in a garage or storage shed, or does it need to be on the exterior of the building? Sorry, Dave, you're muted.
The short answer is no. It needs to have quite a bit of air to pull heat from. So you really couldn't put it in a garage because you'd have to like, leave the garage door open. Well, a storage shed. I mean, you could put it in a shed. Think of it as under a roof for protection, but you still would need some kind of a opening to make sure you can get heat exchange. So, if you had a shed with kind of one end open or something, you could do that. But it does need a lot of air for heating. I mean, essentially it's pulling heat from a big volume of air and concentrate.
Thanks, Dave. And Scott also asked how much solar you would need. Dave, feel free to answer that.
I guess I should go back and look at that, but I'm remembering like just to power the heat pump, let's say for the whole year, if you averaged it out, probably about somewhere around, depends on the size, but let's say 6 kW, something around there. Because remember, the heating is the biggest individual energy thing. But that's I'm going to have to go back and check myself on that. It's been a long time since I've actually looked at that, but I think that's about what we would need.
Yeah, and Scott, to further elaborate a little bit, I think it just really depends on your individual situation, what your electrical loads and usage all look like, to say what it would take to cover your usage with solar.
I mean, lately I've been advising folks to really load up on solar because if you're going to do it, aside from the heating, if you migrate your cars to like plug-in hybrids or full electric, it's really nice. You're essentially getting very low cost or free power for that too. So typically try to load up as much as you can.
Thanks, Dave. Okay, somebody asked, I'm sealing my house. What level of ACH is so tight that an air exchanger should be installed? So I guess what level of tightness?
0.35 ACH is the kind of the cutoff.
That's
But
ACH
I
natural.
yeah, the way I think about it though is I think about it at each level. And so like basements is one area where, I mean, think about it in the winter when you've got everything super tight shut, or in the summer when it's super hot or smoky. And so, I mean, I sort of think that you can count on natural air, but over time, and it's not something, people have been living in their houses for a long time without all this, but if you're going to upgrade all your systems and do this, you really need to think about that. And really, to me, it's if you live in the basement a lot, do a lot of things, and then on the second floor, having something for your bedrooms. So I would, that's sort of my advice to most of my clients is at this time, let's think about it and do it.
Yeah, and if you do get a home energy assessment through Energy Smart Colorado, part of that assessment is a blower door test where they measure your home's air leakage. So the number we typically use is natural air changes per hour, and there is a national standard for that of 0.35 natural air changes per hour. Anything under that, we would generally advise to install some sort of mechanical balanced ventilation system. Okay, Christine asked, does the Excel rebate require a pro contractor install for a mini split? Christine, yes. Generally, Excel requires you to use one of their certified contractors to claim any of their rebates. I believe they host their list online. If not, you can certainly reach out to them to get the list. But yes, and that is different from the contractor list for the state tax credit. But yeah, for any of Excel's rebates, you do need to use one of their certified contractors. Okay. Taylor asked a great question. Are there any options for either air to water or ground source heat pump equipment that can run domestic hot water with the same system, similar to a sidearm boiler setup? Is that recommended?
Yeah, I should mention that. Yes. With ground source, it's a pretty standard. There's something called a de-superheater, which basically when the system's running, it provides extra heat to a called a preheat tank. And that tank will stay anywhere from 80 to 120 degrees. In the summer, the tank is so hot. And then that tank will feed like the simple setup is you just have a standard little electric water heater or a gas. And so you've essentially way preheated your water and you hardly use any energy to top it off and make sure it's consistently like 120. You can also do with the air to water, you can set the piping up so it can do the DHW. Also, I think the downside or the only thing you have to be very careful of in designer is to make sure that when you're running that at full capacity for the heating, you have enough to keep doing the water also. And it's probably going to be wise to combine it like, okay, it's a preheat and then other. So yeah, that's a good point. I should add that in. But for both of those systems, preheating is a very good benefit.
Great. Well, thanks, Dave. I'll give, if there are any last second questions, you can throw them in the Q&A, or if you'd like to raise your hand, I can unmute you. I'll give folks just a second if there are any last minute questions.
Thank you everyone for attending.
Yeah, not seeing any hands raised or additional questions. So yep, thanks again for joining us. We will follow up with some additional information, slides, and a link to this recording. So be on the lookout for that. Feel free to send it on to anybody you might know who wants to learn about these heat pump systems and all the incentives that are out there. So thanks for joining and have a great night, everybody.